Hello everyone, in today's video I will be solving a problem based on moment area method for a simply supported beam, and in short simply supported beam can be written as SSB. So here this is a simply supported beam, and here at the mid one point load is acting. Let it be W, and the length from this end to this end is L, and let's assume this end as A, this as B, and this as C. Okay, now the deflection of this type of beam, how it will look like this. Okay, so the deflection will be like this, A, B, and here the maximum deflection will occur at C, the max. Okay, and here for a simply supported beam, here the slope will occur, let it be theta at A, and here theta at B, and at A and B point the slope will be maximum, and at this point C the deflection will be maximum. Let's write like this. These are the important points here in this beam. The first point is at A and B. At this and this point the deflection will be 0. Okay, and the second point is at this point, C point. At C point deflection is maximum, and the third point for this simply supported beam is here at C point. What happened? Slope will be 0. Slope will be 0, and fourth point at this A and B point slope is maximum. Okay, now here the bending moment diagram for this type of beam will be, it's a simply supported beam where at the mid point load is acting, A, B and C of W load and L length. So the bending moment diagram for a point load is like this, right? So this is the bending moment diagram, and for this type of bending moment diagram, what happened if we need to find the area of this type of triangle? What we have to do is we have to separate this into two terms, and we can find the area of this half part, and this half part is equal to this part, right? So to find this area, what is the formula? Area is equal to half into base into height, right? So this is the formula for finding a area of a triangle. And now suppose we have to find the CG distance. CG is always act at the center, so this is the center of gravity. So now from this one, from B point, if we have to find from this point to this center of gravity, so the formula will be from 2/3 of the L, and from here to this center of gravity the formula will be 1/3 of L. And these are the most important things which we have to remember. Okay, now same like for a simply supported beam. Suppose this is a simply supported beam. In this case what happened? Point load was acting, but for this case here suppose a UDL load is acting. So for this type of beam the bending moment diagram will be like this. UDL means it will be a parabolic, right? So let it be A, and B, and W loading of L distance. So here the maximum bending moment will occur at the mid. Maximum bending moment is denoted by B max. So now this is the bending moment diagram for this type of beam. Now how to find the area for this type of beam? Area is equal to the formula. Suppose this okay, here also we'll separate this part, and this part is equal to this part, right? So if we find, we can easily get the value for both, right? So now for this type of, this is not a triangle, okay, it's a parabolic, right? For this type of shape, how we'll find the area? That is 2/3 of h into L. H is nothing but this is the h height and this is the length. And now see, now CG is acting at the center. So from B point, if we have to find the CG distance, then the formula is 5/8 of L, and from this midpoint to this distance, CG distance, if we have to determine this length, then the formula is 3/8 of the L. So these are the most important things which we have to remember, and these are some of the points which is very important to know for this type of cases. Okay, so in the next video I will be solving a problem based on simply supported beam. Okay, thank you.